Welcome to the Greedy Paradigm lecture series. Today, we will discuss the fractional knapsack problem using greedy strategy. So before going into the detail of the algorithm, let us first develop our intuition through a very simple real life analogy. Consider a gold merchant who wants to fill his limited capacity bag with the most valuable gold possible. And at every step, he must make a choice: either take the lightest gold or the most expensive gold or the gold that gives the best return per unit weight. So these are the three choices he has decided. So as we know that the merchant has a bag with a limited capacity and he has several gold bars of different weights and values. Since gold can be cut into smaller pieces, the merchant can take a fraction of any bar. His goal is to fill the bag in such a way that he obtains the maximum possible profit. So, among these three choices, one of these choices was to take the lightest gold. Second one proposed as the most expensive gold base, and the third one, the gold that gives the best return per unit weight. Among these three choices, he has to select the any one among the three so that he obtains the maximum profit possible. So at each step, the merchant can follow these three different greedy strategies. So the merchant first select the lightest gold bar available that I told. In this case, a lighter bar may not provide maximum value, and the merchant may end up carrying more gold but earning less profit. It may happen. The thinking of the merchant's mind was, if I take lighter gold plate pieces first, I can fit more pieces into my bag. So based on this intuition, the merchants decided at first select the lightest gold bar available. But again, I repeat, the problem which arises, a lighter bar may not provide maximum value. Maximum value means maximum profit here. And the merchant may end up carrying more gold but earning less profit. So merchant may decide to go for the second choice. The merchant selects a gold bar with the highest total value first. That means it is a choice by maximum profit, because merchant think that if I should take the most expensive gold available, then I may earn more profit. But here also a problem lies. A highly valuable bar may be very heavy and consume most of the bag capacity, but preventing better choice later. Okay. So now the third strategy. Third strategy based on maximum profit weight ratio. And the merchant calculates the value per gram of each gold bar. Then he selects the gold with the highest value per gram first. And in that case, the best decision is not always the lightest item or the most expensive item, but it is the item that provides the maximum benefit per unit of capacity. So this comparison actually reveals the heart of the greedy design, that is, choosing a criterion carefully is the key. A greedy choice works only when the selection rule captures the true contribution of an item towards the final objective. And for our today's discussion that we have planned to discuss here, that is nothing but a fractional knapsack problem. The correct greedy rule is maximum profit to weight ratio that we will obtain at last. So, from this analogy, now we are entering into the problem statement of fractional knapsack problem. Okay. So, what is fractional knapsack problem? In this case, we are given n number of objects. You just try to connect with the analogy which I discussed now with this problem. Here we are given n number of objects, like n number of gold bars and a knapsack or bag. Here object number I, that may be first object, that may be second object, whatever, has an weight, suppose Wi, and the knapsack has a capacity, suppose it is M. If a fraction, suppose xi, where the value of the fraction may be 0, maybe 1 or in between, of the object number I is placed into the knapsack, then a profit is earned. And the profit is quoted as Pi multiplied by Xi. Why Pi only? Why not Pi only? Why it is Pi into Xi? Suppose you have selected the first item and your bag capacity is, for an example, 20 kilogram. And the item or the object which you have selected at first, don't assume that you are going for any criteria specific. Assume that you are having one criteria, selection criteria, applying which you have identified the very first item. And the very first item is of having weight 10 kilogram. As your knapsack capacity is 20 kilogram, you are allowed to put full 10 kilogram in the bag. So in that case, the fraction value x of I will be 1. That means you are utilizing full item. So if the profit of that particular item is 1.5, that is 15 unit, this 15 unit actually indicates if you are utilizing full 10 kilogram of the first item, then you are expected to generate full profit. So as you are utilizing full item, so your fraction value, which is xi, becomes 1, and your profit, that is profit unit, suppose it is 15 into xi, that is 1. So ultimately you are gaining full profit. So that is why it is represented as Pi into xi. Fine. And the objective is to obtain a filling of the knapsack that maximizes the total profit earned. And since the capacity is denoted by, for an example, here it is M, so we require the total weight of all chosen objects to be at most M. So what is the gist of it? Suppose in this illustration, you are finding that you have a knapsack with capacity 20 kilogram. So you have altogether 3 items. Item 1 is of having capacity 18 kilogram. Here 25 indicates if you utilize full 18 kilogram, you are earning full profit. That is 25 unit. Second item is of having capacity 15 kilogram. If you are able to take full 15 kilogram put into your knapsack, then you are earning full profit. That is 24 units. The third item is 10 kg. If you are also utilizing full 10 kg, then you are earning full profit. If you select 50% of second item, that means 7.5 kilogram, then your profit will be 24 into 50%. That means 12 units. So the amount of item, that is the percentage of item you are pouring into the bag, with respect to that percentage, your profit will be generated. So a greedy person is waiting. He is thinking that how shall I fill up the knapsack to earn maximum profit? Okay. So if somebody utilize full 18 kilogram of the first item in the bag, so the remaining capacity becomes 20 minus 18, that is 2 kilogram. So neither you can select second item in full or you can select third item in full. So this is actually the scenario. So that is why we have demonstrated the problem as we will be given n number of objects and the knapsack. Knapsack have some capacity. If there is a fraction of an object, for an example, I is placed into the knapsack, then a profit Pi into Xi is earned. The objective is to fill up the knapsack in such a way so that we can earn maximum profit. And since the capacity of the knapsack is denoted by, for an example, M, then we require the total weight of all chosen objects should be at most M. So this is the problem statement. And you just find out one statement written here. If a fraction xi 0 less than equals to xi less than equals to 1 of the item is I is chosen, then a profit Pi xi is earned. So we have to maximize the profit. So this is why it is written maximize summation I equals to 1 to n pi into xi subject to the total weight of the items you have poured into the bag, that should be less than or equals to m. And here also wi multiplied by xi is less. Why not wi alone? Because wi alone is not sufficient to represent the weight, because you must know how much percentage of the item you are actually considering. So if you are considering 50% of the item, then xi will be 0.5. Then if you are choosing second item, then wi becomes 15. So 15 into 0.5 becomes 7.5. So you are actually utilizing 7.5 kilogram of the item number 2. And here the summation is also significant. Summation means you are adding all the possible combinations you are considering. So if you have considered first item full, then your profit will be 25 into 1, because you are utilizing full first item. Then if you are utilizing second item, for an example, 50% for an example, then your profit will be 24 into zero point 0.5, that is 12 unit. And if you are rejecting third item because the capacity is filled up, then your third item profit 15 will be multiplied by 0, because you are not utilizing third item. So that is why the range of xi is given in between 0 and 1. That means you may utilize the item in full, then xi becomes 1. If you can reject the item in full, then xi becomes 0. If you can consider the 50%, 75%, 80%, 10% of the item, then xi will be calculated accordingly. And as per the value of xi, your weight will be decided of a particular item, and your profit will also be selected. Okay. So there are two very important lemmas here. In case of the sum of all weights is less than or equals to the capacity, then xi equals to 1, that you know. And lemma 2 says all optimal solution will fill the knapsack exactly. That is as usual. But here the greedy person has three proposals, and which is similar as the three choices. The person may suggest select the item with highest profit, because the intuition behind it may be the fewer items but more profit. That means initially the greedy person can capture the item having highest profit, because he or she may think of that it may be fewer items but more profit, because initially I am gaining much more. Second proposal may be based on weight. Somebody or the greedy person may think of, I may consider more items chosen means more profit. More item chosen means you have to select the item with minimum weight. The item having minimum weight, if you put into the bag, then you have the remaining capacity of the bag will be more, so that it can accommodate more number of items in future. So this is the logic behind, or the intuition behind proposal 2. That means more items chosen means more profit. And the third proposal, select the item with maximum profit weight ratio, because a balance between the rates at which the profit increases and weight used, that is maximum profit per unit of the weight. So among these three proposals, these are the three choices, because I told in my first lecture that every greedy algorithm is carrying some choices, and among these choices the feasible solutions will be generated, and among the set of feasible solutions you have to identify which one is an optimal one. That means which one is the best one. If it is a maximization problem, you have to pick up the solution having maximum value. If it is a minimization problem, you have to pick up the solution having minimum value. So here our objective is to maximize the profit. So among these three proposals, I have to take the solution, or to select the solution which earns maximum profit. So without losing time, first of all, let us solve some problem, so that we can better understand the actual scenario behind this fractional knapsack problem. So let us go for an illustration of this, a numerical of this problem. So here we have three items. You just see that we have three items. So here n equals to 3. So here we have three items. Just let me select the pen here. Okay, uh, fine. So here we have three items. Uh, sorry, fine. So here we have three items. Sorry, let me go back here. So we have altogether 3 items and capacity of the knapsack is 20. So here our selection is based on the item with the highest profit. So item having highest profit will be chosen first. So first item is of having profit 25 and weight 18. Second item is given as the profit 24 and weight 15, and the third item is of having profit 15 and weight 10. So it is decided that based on highest profit is actually the first item is of having maximum profit. So we have to choose the first item at first. Okay. So what is the weight of the first item? 18 kilogram. So what is the capacity of the knapsack? Capacity of the knapsack is 20 kilogram. So without any hesitation, I can put the full 18 kilogram into the bag. Okay. So once I can put the full item into the bag, then the corresponding xi, that is the fraction value of the first item, that means x1 will be 1. So first of all, you must know the significance of this. So let me draw one vector here. The vector is called actually the solution vector. Okay. Actually, it loads the contribution para of the items into this problem. So we have altogether 3 items. So the length of the solution vector will be n, that equals to 3. So here it is 1, it is 2, it is 3. So x of 1, x of 2 and x of 3. So you are loading the value here, which is nothing but the reflection of the contribution amount of the contribution factor of the item. So if x1 equals to 1, that means you are utilizing full item. So here x1 equals to 1 because you are utilizing first item in full. So then what will be the total weight you are uh, selecting to put into the bag? That is Wi into Xi. So 18 into 1, that is 18 unit full, 18 kilogram full. So then you have to calculate the remaining capacity of the bag. Remaining capacity of the bag is 2 kilogram. As simple as that. So first item gone. So what is the solution vector field of the first item? That is 1. Fine. Now we move on to identify the next item having maximum profit here. So fortunately the second item profit is 24 units. So we have to take the second item. But item 2 is chosen next. Only a fraction of 15 kilogram is put into the knapsack because you cannot put all 15 kilograms into the knapsack because remaining capacity is only 2 kilogram. Then how much you can put into the bag? That will be decided by the field of the solution vectors. So you have remaining capacity 2 out of 15. So 2 by 15 is the contribution of the second item into the bag. Then what about the total weight of the second item to put into the bag? That is nothing but W2 into X2, and W2 means 15 into X2 means 2 by 15. So only 2 kilogram from the second item you can put into the bag because remaining capacity is only 2. Fine. So what is the ratio of the, what is the contribution of the second item? 2 by 15 of the weight of the second item. So after that, no weight remains in the bag. So you have to reject the third item. Once you reject the third item, the solution vector field of the third item will be 0. So what is the solution vector generated here? 1, 2 by 15, and third one is 0. So this actually reflects the contribution percentage factor of each and every item into the first selection criteria. So the x1 equals to 1, x2 equals to 2 by 15, and x3 equals to 0. So what is the total profit earned? Total profit is P1 into x1 plus P2 into x2 plus P3 into x3 because as per the formula you have noticed 1 I equals to 1 to n Pi into xi. So P1 into x1, that is 25 into 1 plus P2 into x2, that is 24 into x2 means 2 by 15, that is the contributing factor, plus P3 into x3 means 15 into 0. So total profit earned is 28.2 unit. The greedy person may think of that he is the gainer. So at that time, another solution comes into his mind. That is the select the item with minimum weight. So here the 3 data are given. So first item is of having weight 18, second item is of having weight 15, only the third item is of having weight 10. So you have to select the item having minimum weight. So third item will be taken first. So here you are also deriving the solution vector. It is x1, it is x2, it is x3. You have selected the third item first. Then you have to identify the weight of the third item, that is 10 kilogram, which is within the capacity of the knapsack, which is 20 kilograms. So without hesitation, you can put the third item in full. So when you can put the third item in full, the contributing factor that will be x3 equals to 1. x1 for first item, x2 for second item, x3 for third item. So then what is the total weight? As simple as that W3X3, which is nothing but 10 into 110. Remaining capacity means 20 minus 10, 10 kg. Then identify the next item having next lesser weight. Now it is second item having weight 15, third item 18. So you have to take the second item. But second item is of having weight 15, remaining capacity is only 10. So definitely you are not allowed to put all 15 kilogram into the bag, rather a fraction of the 15 kilogram into the bag. So what is the fraction? Fraction is nothing but the remaining weight divided by the weight of the current item, that is item number 2. So 10 by 15. So this is the contributing factor. So how much second item will be put into the bag? That is W2X2. W2 means 15. X2 means the contributing factor, that is 10 by 15. So 15 into 10 by 15 means 10 kilogram. Remaining weight 10 kilogram, and you are allowed to put 10 kilogram from the second item. So after second item is put into the bag, there is no remaining capacity. Remaining capacity becomes 0. So unfortunately, first item is not selected. So once the item is not selected, its contributing factor will be 0. So x1 equals to 0. So what is the total profit? As simple as that, as per the formula P1 x1 plus P2 x2 plus P3 x3. And as per the calculation, it is 31. 25 into 0 plus 24 into 10 by 15 plus 15 into 1 makes is 31. So initially the person thought that he was the gainer, having the total profit 28.2, but now the person thinks I am the gainer here. I have the profit 31. So now the last choice. Last choice is based on the profit weight ratio. So first of all, we have to calculate P1 by W1, P2 by W2, and P3 by W3. Among this, you have to identify which one is the maximum ratio. Maximum ratio holder is the second item. So you have to pick up the second item first, highest ratio first. So here also you will calculate the solution vector as usual. It is x1, it is x2, it is x3. We have selected the second item. So we have to fill up x2 first. So what is the weight of the second item? That is 15 kilogram. Yes, it is within the capacity of the knapsack. So you can utilize full second item. So full second item means x2 become 1. So what is the total weight to put into the bag? That is W2 into x2. It is nothing but 15 into 1, 15. So now our objective is to calculate the remaining capacity of the knapsack, which is 20 minus 15, 5 kilogram. Now we have to identify which one is the next size ratio, that is 1.5, which is the item number. Item number is 3. So item number 3 is chosen next. But remaining capacity is 15. Item 2 is of having weight 10 kilograms. So it is impossible to put full 10 kilogram in the bag. Only a fraction of the 10 kilogram can put into the bag. So what is the fraction? Which is the fraction that is x3. Why x3? Because item number 3. Then what is the calculation of the fraction? Remaining weight divided by weight of the third item. Remaining weight means 5. 5 by 10, that is the value of x3. So x3 becomes 5 by 10. So what is the weight taken from the third item? W3x3. W3x3 means W3 is 10. X3 is 5 by 10. So 5 kilogram is only allowed to take from the third item. So after that, there is no weight remaining, 5 minus 5, 0. So you have to unfortunately reject the very first item. So once you reject the first item, its solution vector value, that is the contributing factor, will be 0. So what is the total profit? P1 x1, P2 x2, P3 x3, summation of those three quantities. So 25 into 0 plus 24 into 1 plus 15 into 5 by 10, that is 31.5. So now the third person claims that yes, I am the real winner because I have generated 31.5 unit of profit. So the conclusion says we will move on to the ratio-based approach. Ratio-based approach is preferable. So if you move on to the previous slide, I have given three proposals. Proposal 1, select the item with highest profit. It got the value 28.2. Second proposal is on the minimum weight. It is given 31. Third one, 31.5. Apparently, it is only 0.5 difference, but it is considered as a best one. So proposal 1, that is highest profit base 28.2, second proposal 31, and third proposal is 31.5. So we are accepting the third proposal. So uh, in gist, you will be given a knapsack with capacity given. Yeah, you will be given a number of items along with their weight and profit. Finally, you have to generate the solution vector. Solution vector will tell us the contribution of each and every item, based on which you will calculate the total profit. You will identify the profit, which is the maximum from among these three proposals. Three are the feasible solution, but the optimum solution is the third one. One interesting thing here, why it is called fractional. You just notice one thing. In the first case, once you are considering item number 2, you are not utilizing the full item. You are taking the fraction of the item, and the fraction is 2 by 15 of the second item. So after this second item, no item will be coming. And here also, after the second item, no item is coming. Here also, after this third item, no item is coming. So once you get a fraction of a particular item, that may be the first item, that may be the second item, that may be the third item, it is actually the last selected item. After that, no item will be coming, because fraction indicates it is a fraction of an item which will be selected at last. After that, there will be no remaining spaces into the knapsack. You are considering fraction because of you are not able to put full weight of the currently selected item, because remaining weight is less than the weight of the currently selected item. That is why you are going for the fraction of that item. So only you can take a fraction of the last selected item, and after that no item will come. Okay, so that is why in the first case, item number 3 contribution is 0. In the second solution, item number 1 contribution is 0. In the third solution also, item number 1 contribution is 0. So in the solution vector, there will be a single fraction value. Okay, and it is the fraction value of that particular item which will be selected last. After that, no item can come or join into this problem. So that is why this is called the fractional knapsack. So you are allowed to take a fraction of the last selected item. After that, no item will be coming. It may happen, for an example, that your knapsack capacity, for an example, is 50, 50. You have the first item, suppose capacity 20, second item having capacity 15, and third item having capacity 5. Or for an example, 15. Whatever may be the profit, I'm not worried about it, because I am talking about their weight. Okay, fine. So here also, just a minute. So here also, you just see whatever may be the ratio, this item may be selected first, this item may be selected first, this item may be selected, but whatever may be, you just sum all those three items, you will get 50. So this is a situation where all items can be utilized in full. If you can select the first item based on the ratio, then remaining capacity becomes 30. Then if you select the third item as per the ratio, I do not know what would be the ratio, then 30 minus 15, 15 is the remaining. Then you go for the second item, 15 minus 15, 0. So in that case, solution vector of this particular example will be first item full, second item full, third item full. That may happen. Or even, for an example, your bag capacity is 20. First item is of having 30 weight, second item is of having 15 weight, and third item is of having 18 weight. Okay. But unfortunately, the ratio of profit weight ratio of the first item is the highest. So you have to choose the first item, but your capacity is 20. You are choosing the first item. So at the very first time, your solution vector for the first item is 20 by 30, because you are not allowed to take the first item in full, but first item profit weight ratio is the highest. So you have to take the first item first. but first item is of having capacity 20, 30, weight 30, but the bag capacity is only 20. So you are not allowed to take the full first item in the bag. You are only allowed to take 20 kilogram out of 30 kilogram from the first item. So remaining two item will not be taken. So what will be the solution vector in this case? 20 by 30, second item 0 and third item 0. So this may happen. So that is why it was told the value of the solution vector will be 1. So it was told that the value of the solution vector will be 0, 0 less than equals to xi, 0 less than equals to xi less than equals to 1. So the value of xi will be in between 0 and 1. If all the xi's are 0, that is impossible. If all the xi's are 1, that means you are utilizing all items in full. If some of the xi's are 1, some of the xi's are 0, some 1, only one xi may be fraction, then it may be any one among these three examples. So the value of xi will be at maximum 1, minimum 0, or in between a fraction. And keep this in mind, in the solution vector, only one value will be fraction, and that indicates the item having selected at the last. Selected at the last. So this is about fractional knapsack problem. In my next lecture, I will try to cover the algorithm. For this, I will solve the same problem the way that computer understands, then we will derive the algorithm. So up to this, thank you.